Hello again, everyone. Now we will continue from our previous video, part 3 previously, which we have covered up to branching and also counter. Branching and counter. So in part 1 we covered introduction and basic of assembly programming, and then we covered read-write, arithmetic and logic, and then branching and counter. The reason is I was supposed to cover up to the end, but it seems like the video has become so lengthy, and I don't believe that if it's too long, then it will cause you to losing focus. So that's why I put the video in smaller chunks of less than 1 hour. The previous one was 40 minutes if not mistaken, but if I got it for 20 minutes, I think probably better. So some parts will be 20 minutes, some parts will be like 40 minutes. Okay, the shorter actually the better, as long as you get the knowledge or the skills that you need. Alright, we will cover for this one, this video lecture, we will cover if-else and subroutine, and we'll see whether or not we could go up to lookup table and timer and delay. It's because that all these parts are about programming, sample program. So if I were to explain each of the sample program, it will take a very long time to finish them. Right, creating loop using assembly, okay, using counter. I think we have covered this partially previously, right? But still, I'm gonna cover this as well in this video, so that I could give you a better overview of how to do the programming using assembly language. All right. To do this, I have an intention to use these different slides. So I would rather write down the programming from the very beginning. So basically, what does this program do? Okay, we are going to design a loop, okay, which stops if certain criteria is met. Whereby in this case we have address, location, and then we are looking for some sort of content. In this case the content is 0 times 5a. Okay, let me put it here, content or number 0 times 5a, and then the address starting from 0 times 20. Okay, let me zoom in a little bit for this one so that I could have a better font. Can put it there. Right. Okay, now the content is 0 times 5a, address is 0 times 20. So how do we make the program? First of all, you have to declare this address. You can use these numbers directly, but for better programming practice, we name it as something else. Okay, so content is actually a data. I'll just put data EQU equals to 0 times 5a. So the data is the one that we are looking for, that we want to search whether this data is available in the database. And then we look for address. I'll just put a DDR state. So this EQU 0 times 20. So meaning the address starts from 0 times 20 let's say we have a stack of address like this. Okay, this is 0 times 20, 21, 22, 23. So we want to look where in this list of addresses, okay, from 20 to 23, for example, where is the data that has the number of 0 times 5A here? Here could be 0, 0, 1, 0. Okay, just a random number, just put it there. Okay, could be 4, or it probably could be more, but we want the program to search first line here, and then it will search second line here, search third line here, search fourth line here. Meaning what we're going to do is we search the data one by one throughout the memory location. Okay, after this address, we declare it as the label here. And now what we need to do is move LW. Oh, sorry, this one should go a little bit to the right, indented. Move LW address, okay, and then move WF. All right, where we're gonna place the address. Okay, in this case we're going to use indirect addressing. So indirect addressing, we will be using FSR register. Okay, move WF FSR register. So from from working register we move it to FSR, and then we need to load the data that we are looking for. So move LW data. Right, so we're going to create test here, not test, it's now a label loop, and then all right, now we are going to compare the data for each of the address. So how are we supposed to do that? Okay, let me start with let me use XOR. Okay, okay, let's look at the XOR instruction. XOR WF, F and D. Okay, D is the destination, F is the memory location. Okay, so XOR WF. So we XOR from register W and register F. Okay, XOR WF. I'm going to use I and D F, comma 1. So I'm using indirect addressing, which will refer to FSR. FSR is what? FSR is this number. Okay, address of 0 times 20. So XOR WF I and D F1. Okay, and then after that, what am I going to do? I'm gonna bit test F, skip if clear. Okay, and then okay, skip if clear, and then status 2. Okay, what are we doing here? Actually, is we check the status register. Okay, let me put a status register. Okay, there are 8 bits in this register. Okay, so we have bit 0, bit 1, bit 2. Bit 2 here is actually Z flag. So when you do XOR, the number W between W is what is the W register? W register, just now we have move LW data. Okay, 0 times data is what? 5A. We XOR them with what is shown by FSR. Okay, so what is our FSR? 0 times 20 is 0 times 0, 0, meaning what happens here is you XOR 0 times 5A and 0 times 0, 0. Okay, XOR, what you get is 0 times 5A. Okay, how do you know this number is correct or not? You look at truth table for XOR, 0, 0, 0, 1, 1, 0, 1, 1. So XOR, what you get is 0 and 0 will become 0. If one of them is 1, the answer is 1. If both of them is 1, the answer is 0. Alright. So meaning, if you have the same number, 0, okay, 0 times 5A is actually what? Okay, 5 is 0, 1, 0, 1, and then A is 1, 0, 1, 0. Okay, and you compare with, let's say you have another number which is the same as 5A, then you will become 1, 0, 1, 0. So what is the result here? Here it becomes 0, 0, 0, 0, 0, 0, 0, 0. So what, when the answer is all 0, Z flag is equals to 1. Okay, Z flag is equals to 1. When Z flag is equals to 1, it will not skip. Okay, it will not skip. So in this case, what we want to do, if the number data that we check is the same as the one that is shown in the address in the memory, so meaning we found the data, so what do? We go to next. Okay, we want to go for the next instruction. Next, it will be here. Okay, let's say if it's not the same, the data is not the same as the one in the number that we're looking for. So what do? We want to repeat the process. Okay, but before we repeat the process, we need to update the next address. Just now what the address was 0 times 20. So the next one if we want is 0 times 21. So how do we do that? So we have to increase FSR. Okay, 1. Okay, let's double check. INF, increase F. Okay, register F, and then D is the destination. So our destination that we want is the FSR. Okay, FSR, meaning here is FSR plus 1, we save it in the FSR. So FSR is showing the new address, which is 0 times 21. Okay, and then after that we want to go to loop. So what happens here? Okay, we repeat the process. Okay, we repeat the process. So our working register, W register, is still having the same data. Okay, from here, and then XOR with INDF1. XOR INDF1 meaning it will XOR with the data shown by FSR, which is 0 times 0, 1. If it's not the same, okay, like this case, for example, not the same, meaning Z flag is 0. Okay, so skip, it says here skip if clear, meaning skip kalau Z, if the Z is 0, then it will skip. Okay, so it will not exit. Okay, it won't go to the next instruction. All right, so it will increase FSR pointer, and then repeat again until you find exactly the same data. Okay, the content is in the register is the same as data, so the results will be like this. Okay, let's say your data is 0 times 5a, and then your address, in this case 0 times 22. Okay, this address, okay, have the same number, so the result here will be 0000, and Z flag will be 1. When Z flag will be 1, here bit test file as skip if clear, so now it's not clear, not 0. Clear means 0. Okay, remember you have to use skip if clear means 0. If set meaning if the Z flag is 1. So in this case we have Z flag is equals to 1, so it's not clear. Okay, not 0 value, so it does not skip. So it will execute this instruction, and then it will go to next, which means it will exit the loop. Okay, we will exit the loop. So this is the process of how this is done. All right. So this program is actually comparing the data, literal data, to the data in the registers. All right. Okay, that is the counter just now, right? Next, next is the how to create the if-else structure. Okay, so let me go to the next page, and let's do the if-else structure. Okay, if-else structure. Right. What is important in this if-else structure? If you if you're familiar with C programming language, the structure of if-else will look like this. If something like condition 0, for example, okay, task 1. Okay, this is the program code for task 1. Else, if condition 1 equals to 0, you have task 2, right? And then else if, or I'll just put else only. Task 3. Task 1, task 2, task 3 depends on whatever the program code that you need to have. Let me just push it upwards so that we can see the whole story here. Okay, so now I can see this whole thing in one page. All right. So how do we do this in the assembly language? All right. So the first thing we do in this subroutine, we test with bit test test F, skip if clear, right? And then condition 1. Okay. Let's use a port number. Okay. Let's use port A 0, for example. Okay, so meaning you're testing pin 0 from port A, okay, whether or not it is on or off. Okay, in this case, let's say we have your PIC here and then your port A. That's the ground, and then that's your switch. Okay, so the switch, if you push this, then it will this pin will become 0, meaning 0 is on. Okay, so bit test F, skip if clear, meaning skip if 0. Right, so what do we do? Go to, let's take task 1. Okay, I'll put LED 1. Okay, the question asks whether the question for this, not the question, the example, this example shows when the switch 1 is pressed, A0 is pressed, we want LED 1 or LED 0 to turn on. So we make it go to LED 0. Okay, so LED 0, there's one label here, LED 0. Okay, move LW 0 times 01 MO, move WF port B. So meaning we put 0 times 01 to port B. Alright, let's say LED's switch 0 is not on. What will happen? Okay, if switch 0 is on, meaning the answer, the output is 0, so Z flag will become 1. So skip if clear, so Z flag becomes 1, it will skip. Sorry, when Z flag becomes 0, it will skip. Okay, when Z flag is 1, it will execute this. Go to instruction. Okay, meaning if the switch is pressed, it will go to LED 0 instruction. Right, and then here go to exit. Now we want to test bit test F, skip if clear port A1, for example. So switch 1 goes to port A1. Just now switch 0 goes to port A0. So we want LED 0 on. And this one we want LED 1 to be turned on. So port A1, so we go to LED 1. So we have one instruction, LED 1, the same thing as this one. Just copy and paste it here so that I don't have to rewrite it. So 0 times 0, 0, 2. Okay, port B. And then we have another one, bit test F, skip if clear, port A2, then go to LED 2. So we have another one here, LED 2. I'll just copy. Okay, for the sake of reducing time to write. Alright, so now we have LED 2 here. Move LW 0 times 0, 3. Let me check whether we do it correctly. Here is 0, 0, 0, 0, 0, 0, 0, 1. Okay, 0 0 0 0 0 0 1 0. What is 3? No, we don't want 3. We want actually 0 1 0 0, meaning 0 4 here, right? Because we want to turn on LED 3. This is LED 3. This is LED 2. This is LED 1. Alright. Sorry. LED, we start with LED 0. This is LED 1. This is LED 2. Right. So what's next? Okay, so what happens if this one is not true? Okay, if this condition is not true, it will actually execute this thing, LED 0. So what you need to do, if the condition is not true, you have to have another line, go to exit, meaning if all the if all the switch 0, switch 1 and switch 2 are all off, which means it tells here this one is off, this one is off, this one is off, it will execute this. Okay, if you don't have this, then it will execute LED 0, meaning it will turn on LED 0. So that's not what we want in this program. So we want it to exit, so we have to have an exit here. So exit is actually at the end. Okay, if you consider this as a subroutine, it will execute the subroutine and then exit from the subroutine. So in this exit here, whatever the program that you want to do, or to continue from the previous program, or it's up to you, right? So this is the case where we check the switch one by one, meaning it happens one switch is on at one time. There's no case where all three are turned on or two of them turn on. Okay, so this is the program for it. Okay, what happened? Okay, next part in this program. What do you do if you want to have at least two switches to be turned on? For example, switch 0 and switch 1 on, and then switch 2 off. So what you want to do here is you want to turn on LED 1, LED 2, okay, and LED 3 is off. So how do you do this? Because what will happen here, when you check port A0, go to LED 0, execute this, and then exit. So how do you work around this? Okay, one way is you create another name here. You can put it as test, let's say LED 2, and then LED 1. I'll just put test 1. Just now this is considered test 0. This is test 1, this is test 2. So what do we want here? After you're done with LED 0, after you turn on LED 0, go to test 1 to check for LED 1. So it will check LED 1 and then go to LED 1 subroutine, and then once finished, it will go to check number 2, okay, which is the third LED. Okay, after check number 2, if it's not true, then it will exit. Right, so that's it. You can have two switches turn on, and then you can have the appropriate LED to be turned on accordingly. And in this case as well, if you have all three switches are on, all the LED can be turned on in this algorithm. Right, basically we have covered up to the basic of if-else structure. Okay, we have covered up to this point. meaning the ability to check multiple conditions. All right. And then there's another example. Check the content file register. If the content equal to certain data, clear that register. Right. This part I think I'll just leave it to you for you to understand. What's best for you is to understand it. Understand this program code. Secondly, what you need to do is to rewrite the code without looking at the program. This is how you can learn assembly language efficiently. Alright, now let's go to the third part, the next part, which is the subroutine. Right, subroutine. The program in microcontroller, it's being executed in sequence, okay, based on the line of coding. To allow the program to branch or to jump and perform some repeated functions, a subroutine must be created. Meaning, if you want to do something repetitively without having to rewrite the same code throughout your program, then you have to use subroutine. It will save a lot of memory space. Okay, the subroutine can be called and used in the main program. It is especially useful, especially when you need to perform repeated function, as I mentioned just now. Okay, the opcode related with subroutine is call and return. Right. Let's go to notes here. Okay, so let's say we have a line of codes. Line number 1, line number 2, 3, 4, 5 until 10, and then 11, 12, 13, 14. So in line number 1, you start with something register. Okay, EQU 0 times 20. Okay, just a random program code. Then you have a start. I need to have a start. Okay, let's get rid of that. They have start. Okay, and then move, line number 2, move LW. Okay, let's follow the ones like in your slides. Yeah. Like this one, move LW 0 times 23. 0 times 23, and then move WF port A, and then let's say here we call function 1. Okay, so function 1 is located somewhere, let's say here. So the label is here, function 1. And then we have another one called function 2. So there is a function 2 somewhere here. Okay, line number 14 or 15. Okay, so what happens here when you call function 1? The program code will go here. Okay, so you just have here move LW whatever the program code you want, and then when you're finished, you will have to have a return, meaning a return from subroutine. So what happens here is once you have finished the function, have finished doing the instructions, all the instructions in the function, subroutine, it will come back to this point, and then it will call function 2. Okay, let me draw something here so that you can see the sequence. Okay, I'll put a line of codes, line number here, number 1. Sorry, that's too thick. Number 1 here, number 2, okay, and number 3. Sequence is number 3, and then it will jump to this line, number 4, number 5, number 6. Okay, after number 6 it will go to number 7. Number 7, from number 7 it goes to number 8 somewhere here. So number 8 here, let's say I'll just make a copy of this. Sorry. Just make a copy and paste, easier for me. Okay, let's say we have this part, something different. Okay, so this is subroutine number 2. So just now number 7 is here. Okay, step number 7. After step number 7, it will go to step number 8 here. Step number 9, and then step number 10. Return, it will go back here. Right, now the program will go back here. This is number 11. So what it does here, let's say you have nothing here, then what will happen is the program will execute this line 11, and it will come back here. Right, so you need something to finish the program. So we need to have jump or go to. Sorry. Go to finish, for example. So I write down label finish in here. Finish here, and we have end directive. Okay, if not, you before finish you might have something else or whatever that you want. You could probably have something in here. We move it here. So you have let's say you can have any program, whatever that you want to write here. Okay, there's next line of program. So this becomes number 12, and then number 13, and finally number 14 is over there. Okay, these are the sequence of your execution. So this is a function of subroutine. If you see this part, this part, I want to choose something different color. This part, too thick. Okay, function number 1. Let's say we have another one of a different color. So this is function number 2. Okay. So actually you can do many things here. You could even call the function or the subroutine. Sorry, I keep using a function instead of subroutine. In assembly, we call it subroutine, but in C, we call it function. Basically, they're the same thing. So if you get confused when sometimes I call function, I meant actually, I meant for subroutine. Okay, so this one here, I can actually function 1. Okay, and then I could actually have another function 1. I can call function 1 as many as I want. Alright, so and then before I'm finishing, I'll just write go to finish. So this is the end of the program. Besides finish, you could also go to start, meaning you are repeating the program like forever. Okay, but still you have to have some end of instruction, meaning that's the last line of your program code. Right, that's it's about the subroutine. Okay, so every time you call subroutine, there is the program counter, all right, will be saved into stack. Let me show it. Let's say I just assume this is the program counter. Okay, this is the program counter. Okay, up to this point. This is not the actual number. I'm just asking you to assume that this is the number of program counter. So number 4 here. Call function 1. Call subroutine 1. So what happens here? There is a stack memory. You have address number 4. So program counter will go after the function call. The program counter will go to line number 11. Okay, you will do this. Line number 13. Before it goes back to the line number 4, line number 5. Okay, before you go back to line number 5. Okay, it will return back stack to the program counter. So at the moment when you call the function, okay, number 4 here will be saved into stack, and program counter will show number 11, and then it will show number 12, and then number 13. After number 13, okay, when there is this return instruction, the data from stack will be put back to program counter, so it will be 4 there. So at that point, it will come back to 4, and then after that it will execute number 5. So the next one will be 5. Alright, so number 5, call function 2. Okay, call function 2. Okay, after this instruction, what happens is line number 5 will be saved in stack, and then it will go to function 2. Okay, it will go to function 2. I don't know what's wrong, it doesn't change the color. Okay, we'll go to function 2, and the line number in the program counter will become 14. Okay, 14, and then you will be 15, and then 16. After 16, the stack will return. Okay, will return 5 into program counter. So it will execute. It will go back to line number 5. Okay, this is line number 5, and then you will do the next one. Okay, line number 6. So that's how it works in microcontroller. Okay, let's go back to our notes. Right. So basically, this is another way of call a function and then return. Return meaning you go back there, and then call second function and go back, right? Okay, so that's basically how the subroutine. So for subroutine, we use call and then return. Okay, for goto is different. Okay, goto is different. Goto meaning you will go directly. It will not save the program counter into stack. It will go direct to the next label where your label is. Okay, so that's goto instruction. Okay, this is what I mentioned just now. When the subroutine is called in the program, the stack is save the address of the program counter, okay, and then goes to the subroutine and executes it. When it returns to the address of the program counter, saving it, then once you have done with the subroutine, the stack will return the address of program counter. Right. This is another way of doing writing a subroutine. As you can see here is the subroutine, delay subroutine. Okay, then the main program is down here. Okay, you'll just call a delay program. Okay, and then return, and then we'll come back here.